Good morning. Am I audible?
Yes, sir. Good
Yes, sir.
morning, sir.
Okay. So in my last class, I'm talking about recursion, right? So we came across one problem called binary. So here we can write both non-recursive as well as recursive algorithm. So if you'll go for recursive algorithm or recursive binary search, then how we'll call the functions, right? So, sorry. Yeah. So if you are calling the recursive binary search, what exactly you are doing? Given input sorted array, right? 7, 12, 15, 20, 22, 40, like this. So the initial call of recursive binary search is recursive binary search is our input array A, and then the length of the array. The length of the array, in fact, not required. So the start index of the array and sorry, end index of the array. So these are the three arguments required for recursive binary search. And what exactly you are doing? You are dividing the problem into two subproblems. You are dividing the search space into two search space. Okay, for example, in this case, initial call start index will be 0, end index will be 5. And how you can divide the search space into two? So along with these three arguments, you need to take one more argument, that is the search element x. So you first, your start is 0, end is 5. So you need to first find out the mid index m. M will take the value 0 plus 5 by 2, that is equal to 2, right? So you need to compare the search element x with the middle element, that means a2. Now there are three possibilities. Either x matches with the middle element. If it match, let's say x equal to 20. So here 20 doesn't match with 15. So in that case, it is not matching. So what you need to do, you need to check whether x is greater than a2 or not. If it is x is greater than a2, that means x must be present on the right side of the middle element. X must be present on the right side of the middle element. Else, if this condition is not satisfied, then x must be present on the left side of the middle element. So either the search element match with the middle element, or it may present on the right side, or it may present on the left side. So if it is present on the right side, then your search space move towards right. That means the start index will be equal to mid plus 1, and end index will remain same 5. Okay. And in this case, that is happening, right? X equal to 20, which is greater than 15. So your start index is 3, 2 plus 1, and end index will remain same as 5. So basically, your search space now come to this place. Initially, you have 7 elements. Now you have only 3 elements where you need to search the element 20. Are you getting me?
Yes,
Yes,
sir.
sir.
So how will call the functions? Let me write the definition of the function of recursive binary search. Recursive binary search So call will be like this: A start index, N index, and the search element, and it should return the index of the search element, right? If it is present, otherwise it return -1 if the search element is not present in the array. So what you are doing, you are first checking whether uh, what is the exit criteria. Exit criteria is start index greater than N index. So if S is greater than E, then no need to do anything. Simply you exit, you got the answer that element is not present, so return -1. Okay, but if start index is not greater than E, then you need to search. So how you can search? You need to find out the middle index, and middle index will be equal to start index plus N index by 2. Then you have two cases, three cases. If mid x matches with the middle element, then you return the middle index M. Else, if x is greater than middle element, that means x is present on the right side. In that case, you need to call the recursive binary search or binary search with start index will now change to middle index plus 1, and index will remain same, x will remain same. Else, you need to return recursive binary search. Here the start index will remain same, n index will be equal to m minus 1, x will remain same. So this is the definition of recursive binary search. Look at this carefully and tell me if any doubt. Are you getting me? Okay, so here recursive binary search called the recursive binary search. That's why the recursion is taking place, right? And so particularly in this case, if I'll ask you what is the order of function call, recursive binary search. So for x equal to, let's say initial call is recursive binary search, RBS, whatever. This is recursive binary search, whatever. Let's see, binary search. Okay, anyway, whatever. RBS. So RBS initial call is in this case A, start index is 0, N index is 5, and search element is 20, let's say. What is the next call? Can anyone tell me? RBS A0520. What is the next call?
Sir, it will be A3520.
A3520. Very good. Next call. 3 is less than 5. So you find out the middle element. 3 plus 5 by 2. That is equal to 4 is the middle element. And x is less than 22, right? So what should be the call? X is less than 22. A start index will remain same, n index will be 3, 20. Is this correct? Look at this carefully and tell me. RBS A3320.
Yes, sir.
Yes, sir.
What should be the next call? RBS. Middle index will remain same, 3 plus 3 by 2, that is equal to 3, and A3 matches with 20. So there will be no further call. This function itself return what? Return 3. Am I right? No further call. Just return 3. Let's say another call I am giving. RBS A05 10. What should be the next call? Can you tell me? RBS 0510. Next call is. So 10 is the search element. Na? Middle element is 15. 10 is less than 15. So it should be 0, 1, 10. Am I right? Then what is the next call? So middle element is 0. 10 is greater than 0. So RBS A 1, 1, 10. So now middle element is 1 itself and 10 is on the left side. So next call will be RBS A 1, 0, 10. So it is the exit criteria. Start index is greater than end index. Is that clear or any doubt in this? Please tell me.
Sir, after 05, how 01 is?
10 is smaller than the middle element. What is the middle element? Middle element is 15, right? A2.
Yes, sir.
So 10 is less than A2. That means you should shift the search space towards left. So your start index will remain same. End index will be mid minus 1. Na?
Yes, sir.
And equal to mid minus 1 here I have written. Okay. So it will be 0, 1. Mid is 2. So end index will become 1, 0, 1, 10. Then
Yes, sir.
again the middle element you got 0 plus 1 by 2 equal to 0. That means 7. And 10 is greater than 7. So you will move towards right. Then next middle index is 1 plus 1 by 2. That is equal to 1. And 10 is less than 12. So end index will be decreased. Now what do you found of that start index exceed end index? That is the exit criteria. So you will return what? Minus 1. Are you getting me? Okay.
Yes.
Element is not found and you return minus 1. So this program we have already written in code blocks. Look at the recursive binary search here. This is one. Is that clear? Shall I move? Or any doubt here? Okay. Go to your drive. Here is their link is there now. Am I audible?
Yes,
Yes,
sir.
sir.
This link I think I have already shared na?
PX1 and the calendar one has been shared.
So I think all program you can view, no issue. Okay, this is already shared with you. Matrix addition. There are some network issue. Am I audible now?
Yes, sir.
Yes,
Audible.
sir.
Okay, it suddenly disconnected. I don't know why. So I think all code are visible to you, right?
Sir, can
So
you
in
also share your OneNote?
one note, I need to make it directly share. You can view. If I directly share it.
Yes, sir, we can view that.
Okay, just let me check how to share. File, share. Uh, which one? Sir? This is. Uh, one second. CSC. Okay. I think it is shared with you now. And C code. I think this is what matrix addition. Matrix addition. Addition. Matrix multiplication program have I shown to you? How to multiply two matrices? Anyone can respond? Matrix multiplications. Yes, anyone can respond?
Sir, we haven't done matrix multiplication.
Addition?
Addition we have done.
Okay, multiplication we need to show, right? Let me vector file upload. A vector addition I have searched binary search. Binary search. So the binary search. Binary search. Then what next? Remaining binary search, bubble sort, bubble sort, bubble sort, bubble sort. Then what next? Bubble sort. Calendar I have done. Determinant. Determinant is not yet completed. Fibonacci. Okay, remaining I will add gradually. Let me show the matrix multiplications. Matrix multiplication. Mat multiplication is there. Mat multiplication vector addition is there. Add vectors to table is there. Mat multiplication. This is mat transpose. Point transpose. Multiplication, I think, not there. Mat transpose. Okay, let me show the matrix multiplications. File, new project. Mat multiplication. Multiply. So I have to multiply two matrices, right? Let me write everything in terms of function so that you will have the expertise of function also. Objective is to multiply two matrices, right? First you enter size of square matrix, size of matrix A, enter size of matrix A, enter size of matrix A, then scanf ampersand m ampersand n. Is it clear to everyone? So let me declare it. Any doubt in this? Tell me.
Also.
Then you call this, enter A M N. Okay. Here there is something important you have to remember. When you are writing the void function, enter functions, and for entering the matrices, this is the dimension no issue. You can put integer, but here the matrix rows, number of rows are optional, but number of columns you must put a constant value here. It's also a constant pointer, constant value. Okay. And then you write down the definitions of enter functions. Void enter, 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 input whatever you write. Nice. Or anything you can write here. And constant, this should be constant, and it should same as this value. And then you can write integer. So you need to declare two local variable ij, take two for loop for I equal to 0, I is less than m, I plus for j equal to 0, j is less than n, j plus, and percentage t, comma, ampersand x, right? Is that clear? Enter functions? Or any doubt in this? Okay. ठीक है ना? So here you can copy this code. Take the size of matrix V. Okay. Size of matrix V. Then let's say order is P2. PQ. P2. B. Q. Okay. So you enter A, enter B, then print. You can print. We can write a statement here. Printf. Input. Input combine matrix. Percentage. We can write PQ. No issue. Here also you can write the same thing. Okay, maybe I'll run and show you. Enter the size of matrix 2, 3. Input a 2 by 3 matrix. 2, 4, 5, 2 rows, 3 columns, 3, 7, 8. Enter size of matrix B. 3, 1, let's say. So 3 rows, 1 column, 4, 5, 7. Yeah. Are you getting me? Or in doubt? Okay, so you entered. After entering, you need to print. You need to print now. Input part is over. Print A equal to write A equal to A, print A order is MN. Then if you want, you can print B also. Want to see? Sorry. Print B. EQ. Which is the third matrix? C. C. What should be the order of C? C order should be M by, yeah, M N P Q, M by Q. Agree? Then how you can get C? You can get C by multiply, right? Multiply A with Mn, B with PQ, and the result is C. Everything you have to pass as an argument because you cannot return a matrix. C is a matrix, now you cannot return it. So this is how you can call. And if you want to print the result, you can print it. Print C. And what should be the order of C? Order of C is what? Can anyone tell me? C M by
M cross Q.
MQ. But if you want a return value here, if true, if true, if this return 0, zero or -1, let's say -1, maybe you can return something like that. You can do it. Otherwise, you do it like this way. So this is the program. So you have to write the print function, right? So print function you have to write. So how the print function look like? Same thing. Print. You have to put a constant number of column. No issue otherwise. And these are the print functions. copy, both are same. Copy this. Is the print function. Print. Yeah, it should be printed. Nothing else. Put two space. Write this. Put a new line here. First. Print is okay. Another function is what? Multiply. Multiply function is there. Multiply. Multiply return an integer value. Integer. Okay. Constant value here. Integer. Integer. Put some constant value here. Integer. Constant value here. So take this for multiplication. Write down the definition here. This is the definition. Okay. What it does? Can anyone tell me what multiplication function does? Yes. Tell me. Same thing. Am I audible?
Yes, sir.
So how you can multiply two matrices? What is the logic? The first thing is you need to check if 10 is not equal to p. Then what will happen? Multiplication is not possible, right? This is the condition. Then return minus 1. Otherwise you will multiply. Okay. Understood? Otherwise you multiply and you have to take 3 index I, j, k, and I should run from M and its j should run to Q. Okay. And what you need to do? You need to initialize Cij equal to 0. Okay. And you need to compute the value of Cij. So how you can compute the value of Cij? With the help of k. So k equal to 0, k is less than n, a plus plus. Your Cij plus equal to what? K I k into E k. This is the formula. Okay, now if you run it, so maybe 2, 3, 2 rows, 3 column. Then let's say this is 3 by 1 matrix. 4, 5, 6. A equal to this, B equal to this, C equal to this. Are you getting me? Or any doubt in this? Okay, so you join the next class. Now you can leave now. So I'll share this program also, no issue. This is a very good example of demonstration of functions as well as array. You can leave now.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.